All right, so today we are going to start chapter 4. We're going to do solving a system of linear equations. And just to give you an idea, basically what you're going to do is you're going to take chapter 3. So in chapter 3, we had to do linear equations. Oops. So we had to do linear equations. So now we're going to do 2 linear equations. So we'll have 2 linear equations. And what that's going to look like is you're going to have like one line that'll go this way, so you'll graph it. So this will be 1y equals mx plus b. And then you'll have another one. And what you're looking for is where they intersect. So the answer that you're going to get, because you're going to be finding x and y, the actual values, is where do they intersect. So 4.1, I don't know what happened to my objective there. Systems of linear equations. A system of linear equations consists of 2 or more. We're only going to look at 2 in this class. This section focuses on solving a system of linear equations containing 2 equations and 2 variables. So we're going to have 2 equations and 2 variables. So y equals mx plus b. A solution of a system of linear equations in 2 variables is an ordered pair. So you're going to be finding what the x and the y are. So that answer will be a solution for both equations in the system. All right, so objective 1. So it says determine if -3, 1 is a solution. So you have 2 equations. You don't have to worry about solving them for y because we're just going to plug these numbers in. Like we did earlier in the semester where we just plugged it in to see if it worked. So first we're going to do is we're going to replace x with -3 and y with 1, because that's what they are, in both equations. So the first equation, so that's going to be -3 minus 1. So -3 minus 1 is -4. So that is true. Then we're going to do it the second one. So now we've got 2. Let me do this. This is a little bit more in this one. So we have 2 times -3 plus 10 times 1. Well, 2 times -3 is -6. 10 times 1 is 10. -6 plus 10 is 4. That also is true. So then we go up here and we say, well, since the point -3, 1 produces a true statement for both equations, then that is the solution. So that means if I were to graph these, one would go this way, one would possibly go that way, and that is where they intersect. So that would be your -3, 1. All right, so now we're going to do it one more time. So determine whether 4, 2, so this is your x, this is your y, is a solution. So we're going to replace the x with 4 and the y with 2 in both equations. So let me, I don't know what that's there. All right. So the first equation would be 2 times 4 minus 5 times 2. So remember, you're taking the first equation, so you got 2 times 4 minus 5 times 2. So 2 times 4 is 8 minus 10, which is -2. That produces a true statement. In the second equation, we get 3 times 4, which is 12, and 4 times 2, which is 8. But 12 plus 8 is 20. So since this is false, it's supposed to equal 4, and it doesn't. It equals 20, so it makes it false. So this is not a solution. It has to work in both. It's all or none. Okay. All right, so now we're going to graph them. So in order to graph them, they have to be in the form y equals mx plus b. Remember, m is for mountains, and mountains have slope. And b is the number that's by itself. That's your y-intercept, and it's where you begin when you're graphing. So solving a system of equations by graphing. Since a solution of a system of equations is a solution common to both equations, it is the point common to the graphs of both equations. So to find the solution of system of two linear equations, we graph the equations and see where the lines intersect. So it says solve the system of equations by graphing. All right, so the first thing we're going to do is, in order to graph it, it has to be in the form y equals mx plus b. So we have to get y by itself, otherwise we cannot graph it. So we take this and we're going to subtract 2x from both sides. So we're going to take this 2x, we're going to move it over here. All right, so we're taking, we're taking the 2x and subtracting it from both sides. So when we do that, we get negative y equals 6 minus 2x. And then since there's this negative sign in front, we're going to need to divide everything by negative 1. And that gives us y equals negative 6 plus 2x. Now remember, it's the same thing as y equals 2x minus 6. So this is the form that you're more familiar with. All right, so let me move this box. So now we're going to do the same thing. We're going to graph this one. This time we're going to take the x. We're going to move it over here by subtracting it. So we get 3y equals 10 minus x. And now we're going to have to divide every piece by 3. So when we divide every piece by 3, we get y equals 10 over 3 minus 1 over 3x. And again, to write it in the form that we're used to seeing, so negative 1 over 3x plus 10 over 3. So remember, it doesn't matter the order of this as long as it says y equals. All right, so now we're going to graph them and we're going to see that they intersect at 4, 2. Okay, so now we're going to go over here. Let me just delete the box. All right, so when we graph this line right here, remember B is the y-intercept, so that's where we begin. So we're going to begin at negative 6 down here. And then we're going to use the slope 2 over 1. So we're going to rise 2, run 1. And you can continue, rise 2, run 1, rise 2, run 1. You could do it as many times as you want to get a straighter line. They did all the way up to here, okay? This one, and I'll use a different color. So for this one, we'll just use this color. So now we're going to begin, and this is where it gets more difficult if you're having to graph a fraction. 10 over 3 is equivalent to about 3 1/3. So we're going to go 1, 2, 3, and just a little bit above it. And then we're going to go down 1 and over 3. So from here, I'm going to go down 1, 1, 2, 3. And then you have your 2 dots. You can also go up 1. So from here I can go up 1 and backwards 3. 1, 2, 3. And that'll get you 3 dots to make a good straight line as well. But if you'll notice, they intersect right here. So that would be the solution. So if we go and plug that back in, you'll see that it's true for both statements like it was in that very first problem that we did. So if we go and plug the 4 and the 2, so 2 times 4 minus 2, because remember our first equation was 2x minus y equals 6. So if we do 2x minus y equals 6, so we're going to plug the 4 and the 2. So 2 times 4 minus 2. 8 minus 2 is 6. True. And then our second equation was x plus 3y equals 10. X plus 3y equals 10. So we're going to plug the 4 and the 2. So 4 plus 3 times 2. So 4 plus 6 is 10. So that's also true. So that's why that solution works. So helpful hint, neatly draw your graphs can help when you're guessing the solution. Grab some graph paper if you can. It just makes it a little easier when you're working these out by hand. Obviously, when you're working in my math lab, they'll have graphs, but it's always nice to be able to do it on paper. All right, so we're going to try it again. So solve the system of equations by graphing. So we have negative x plus 3y equals 6. Okay, so we're going to take the negative x and we're going to add it to both sides. So we're going to take this negative x, we're going to move it over here by adding it. So then we get 3y equals 6 plus x, and then we're going to divide both sides by 3. So when we do 3y equals 6 plus x, when we divide everything by 3, we get y equals 6 divided by 3 is 2. And remember there's a 1 there, so that's 1 over 3 x. All right, so now we're going to move it down here and get this one to say y equals also. So we're going to take the 3x, we're going to move it over here by subtracting it. Remember, when you move it over there, you always do the opposite. Then we're going to divide everything by negative 9 because there's a negative 9 in front. So now we have y equals 9 divided by negative 9 is negative 1. And then we have negative 3 divided by negative 9, which is 1/3. So now we have negative 1 plus 1/3 x. So now, if you'll notice, they're not intersecting this time, okay? So starting with this equation here, so equation 1, 2 is your y-intercept. So we're going to start at 2, and this looks like it's a little bit off. So it's a little bit off. I guess when I enlarged it, it skewed it just a little bit. So we're going to rise 1, run 3. So we're going to rise 1, 1, 2, 3. Rise 1, 1, 2, 3. And then this one here, you're going to start at negative 1. So starting at negative 1. And you're going to rise 1, run 3. Rise 1, run 3. So what you see is that these are parallel lines. And if you'll notice, their slopes are the same. So when their slopes are the same, they will be parallel, meaning they'll never intersect. So if they're never going to intersect, then how can there be a solution? And that's when we know that parallel lines have no solution. There can be no solution if they don't intersect. Because the whole point is to find out where they intersect. If they do not, then there is no solution. So 0 solutions. All right, so now we have x equals 3y minus 1. So in this case here, I'm going to add this 1 right here over here. So this one is written a little bit backwards. So we get x plus 1 equals 3y. And then I'm going to divide everything by 3. Remember, there's a 1 there. So now I'm going to have 1 over 3x plus 1 over 3 equals y, because those 3's canceled. So there is my first equation. And then this one here, I'm going to take the 2x and move it over here. So I get negative 6y equals negative 2 minus 2x. Then I'm going to divide everything by negative 6. So I get y equals 1/3 plus 1/3 x. And what you notice is that these two equations are exactly the same. So when they're exactly the same, what happens is you only have to graph one line because they're exactly the same. But the problem is when they were parallel, they didn't intersect at all. So there was no solution. When they do intersect, there's one solution. So what happens when the equation is exactly the same is these are called a coincident line, and they have infinite solutions because this solution will work in both because it's the same line. So you have three options. You have the option of lines that intersect. You have the option, and this is one solution. You have the instance where they are parallel lines and there are zero solutions. And then you have the instance where there is the same line and there are infinite solutions. All right, so identify the special systems of equations, of linear equations. So there are three possible outcomes when graphing. One point of intersection is one solution. Parallel lines, there is no solution. Coincident lines, there are infinite solutions. So infinite, 0, and 1. If there is at least one solution, then it's consistent. So if there's at least one, so we have one here, that's at least one. Infinite, there's at least one. So those would be considered consistent, while no solutions would be non-consistent. And if the system defines distinct lines, the equations are independent. So let's look at this. So two lines intersect at one point. So number of solutions, there is one solution. They are consistent and they are independent because they're independent of each other. Parallel lines, if they are parallel, then there is no solution. They're inconsistent because there's not at least one, but they're still independent because they are distinct lines. And then if the lines coincide, meaning it's the same line, then they have infinite solutions, which makes them consistent because there's at least one, but the equations are dependent because it doesn't make up distinct lines. There's only one. All right, so finding the number of solutions without graphing. So this is where we're going to just look at the equations and determine. So since there are only three possible outcomes with two lines in a plane, we can determine how many solutions of the system there will be without graphing the lines. Change both linear equations into slope-intercept form. So we're going to still be working with mx plus b. And we can easily determine if the lines intersect, if they're parallel, or if they're the same line. So without graphing. So we take our first equation. So 3x plus y equals 1. So we're going to take the 3x. We're going to move it over here by subtracting it. So that gives us y equals 1 minus 3x. Second equation, you're going to take your 3x. You're going to move it over here by subtracting it. So that gives us 2y equals 6 minus 3x. And then we're going to divide everything by 2. So when we divide everything by 2, we get 6 divided by 2, which is 3, and 3 divided by 2, which is 3 over 2. So now let's look at our two equations. So we have y equals negative 3x plus 1, and y equals negative 3 over 2x plus 3. So first off, look at their slopes. Their slopes are different. So that means that they're not parallel, and it also means that they're not the same line. So this is going to be one solution. So as we look here, so the lines are intersecting since they have different slopes. So the system is consistent and independent, and it has one solution. Okay, so this is the definition of y. Okay, so you're always going to look at their slopes first. Look at their slopes to see if they're parallel. If they're parallel, then you'll have to look at the y-intercepts. All right, so without graphing, determine the number of solutions. So we're going to take the 3x and move it to the other side. So we get y equals negative 3x. Now we're going to divide everything by 2. And when we divide by 2, we get y equals negative 3x. So what we notice here is this is exactly the same line. So these are your the lines coincide, coincidence. Okay, so that means they're stacked on top of each other, which means there are infinite solutions. And let me scroll down here. I didn't know it was this far down. So the two lines are identical, so the system is consistent and dependent, and there are infinite many solutions. So, well, that would explain why that. Let's see if I can move it up a little bit. That way it's all in the screen. There you go. All right. So without graphing, determine the number of solutions. So first equation, we're going to take the 2x, we're going to subtract it, move it to the other side. So when we do that, we get y equals negative 2x. And then our second equation, it's already set. It's already good to go. It's already in y equals form. So now what I do is I'm looking, so I see the number in front of x is negative 2 and negative 2. So these are either the same line or they're parallel. But this is going to be plus 0, where this is plus 1. So since they have different y-intercepts, this is going to make them parallel. So they're just going to be parallel lines. So the two lines are parallel, therefore the system is inconsistent and independent, and there are no solutions. Parallel lines have no solutions. All right, so that is the end of 4.1, and we will get started on 4.2 next.